There we go. Okay, thanks everyone for joining for our third and this week's final uh, virtual town hall on the Roman core community survey definition process. This is the turn of the high latitude wide area survey to present the status of their work to define the surveys and to discuss how things are going and really to get feedback from the science community. As a reminder of the kind of timeline, these reports are from these committees are due in November, and so this is, well, not necessarily the final time you can provide feedback. This is the last kind of time to provide substantive comments and feedback before they get into the kind of deep writing process. So really would encourage you to make the most of both this session and then ways to contact the committee. Ari Fox just posted in the chat a feedback form, which is one way you can use to contact the committees. And just to say that this is kind of thanks for joining. This is an important process, and we really value you giving me our time to listen to this. So I'll let Ryan take it away on behalf of the committees.
Great. Thanks. Hi, everyone. My name is Ryan Hickox from Dartmouth College. I'm one of the two co-chairs of the High Latitude Wide Area Survey Definition Committee. And I'd just like to echo Tom's thanks to all of you for being here to hear about what we were doing and engaging in the process. And this is kind of, this is something of a new way of doing things for NASA flagship missions in terms of the definition of the majority of the observing time. And we've really engaged a lot with the community input that we've received so far, and we're really grateful for the interest and the time that people have spent thinking about what we can best do with Roman observing time. So just an outline of the talk today sort of comes in two parts. The first one will be a broad introduction to the core community surveys, the High Latitude Wide Area Survey, and the definition committee, and sort of what our process has been so far. That should take about 10 or 15 minutes. And then the second half will go through what our thinking is at the moment. So what our kind of nominal survey plan that we're iterating around is at the moment. And then I'll give you a broad overview in terms of what some of the trade spaces and considerations are. Just a flavor of some of our outstanding technical questions, and then describe some opportunities for input. But we'll have lots of time in the second half of the hour for questions, and so I hope we can have a productive discussion once we're done going through these slides. Okay, so first off, the core community surveys, as I think probably everybody who's on this call knows, the majority of Roman observing time, up to 75%, will be determined by a community process that defines these large surveys with sort of fairly ambitious, as it were, science goals. And the three main core community surveys are the Galactic Bulge Time Domain Survey, which has a high cadence of observations over a relatively small area near the galactic bulge, although it's a few square degrees. For those of you who, hopefully everybody's familiar with the fact that Roman has a very large field of view and has spatial resolution and sensitivity comparable to the Hubble Space Telescope. So, a few square degrees is still pretty big compared to what we could do with Hubble. But so that's the Galactic Bulge Time Domain Survey, and the prime driver for that in terms of the science requirements is exoplanet microlensing. And so the idea is to detect a full census of the exoplanet population, or at least a statistical census via microlensing. But there's lots of other science you could do there, and they presented it earlier this week. Then for the two other surveys, the prime drivers are cosmology. There's the High Latitude Time Domain Survey, which is a time domain survey over tens of square degrees at high latitude, also with spectroscopy. And this is the sort of main goal of this, is to identify supernovae in order to measure the expansion of the universe. And then the survey we'll be talking about today is the High Latitude Wide Area Survey, which is a very large area, thousands of square degrees, including multiband imaging and slitless spectroscopy. And the main aim is to do cosmological measurements via weak lensing and large-scale structure. There's also one other survey that's in definition at the moment. This is the Galactic Plane Survey. This is an early definition survey that was recommended by the Early Definition Survey Committee that will be doing a survey of the galactic plane. So this isn't one of the initial core community surveys, but it's something that is also being defined early by a community process, somewhat in parallel with these other three. Okay, so that's the general landscape. Today we're going to be focusing on the High Latitude Wide Area Survey. And the top level goal for this, just again to touch on what is special about the way that Roman is doing this, is we want to maximize the overall science return while meeting the mission requirements that are focused on cosmology and exoplanets. So there were some specific cosmological and exoplanet science requirements that were defined ultimately by ASTRA 2020 that we need to meet, but there's also a large range of science that can be done with all these surveys, and the actual surveys are being defined by the community. They're the existing survey strategies, and by those, this is sort of the design reference mission, which I'll talk about in a little bit. Their primary functions show that the mission can meet its requirements, but there's a lot of possibilities around that, and that's what we'll discuss today. In terms of the strategy, we have the definition committees for each of the three core community surveys that are going through a whole bunch of steps, and they are providing recommendations to the Roman project. And we also have the Galactic Plane Early Definition Survey doing the same. And ultimately, what we will do is be making recommendations to the Roman Observations Time Allocation Committee, the ROTAC, and then they will balance these all together. Just in terms of timeline, this was the timeline that was presented when the core community survey committees were just being set up. So we had initial requests for community input early last year. We formed the definition committee sort of at the very end of last year, and we got a lot of science pitches and white papers, and these are QR code links to all of those that are archived on a nice website. And now we're in the process of doing investigations, deliberations, and et cetera, and gathering community input, including community discussions like this. And our final report is due in November, as Tom said. Okay, so today we're going to focus on the High Latitude Wide Area Survey. So this is, again, one of these. It has two components. One is an imaging survey over a large area. Its main driver for the requirements, at least for this survey, is weak lensing for cosmology. And so in order to do this, you need a wide area survey with very good angular resolution, well understood PSF. So that's sort of what you get from Roman. You need a combination of both depth and area and near IR photometric coverage. So all of this is optimized by the Roman telescope. We need excellent internal calibration, and part of that will require repeat observations, at least for some of the survey areas. And then we also need deep fields to understand sensitivity limits and systematics. We'll go into that a little bit more later. And also spectroscopic data from both space and from the ground, potentially, to calibrate the photometric redshifts that will be derived from imaging. Then there's also a spectroscopy component. The Roman Wide Field instrument has a slitless spectroscopy capability with both a GRISM and a PRISM. In this case, we're focusing on the GRISM. The idea is to do measurements using baryon acoustic oscillations and redshift space distortions for the overall growth of structure. And we need multiple rolls in order to do this for spectral decontamination, and have to figure out, ultimately what sort of line sensitivity can we reach, and I'll discuss that in a minute. So this is sort of, was framed in terms of being able to achieve the cosmological requirements that were laid out for the mission. But it also addressed another main mission objective, which is just creating a wide field survey with imaging spectroscopy down to deep limits. And so in this case, it's around 26 magnitude. And so in order to do all this, the nominal time allocation that we have for this survey, and so this is an important point as we go along, is that we are limited in time. is 520 days with, and we're, as part of this process, we present what we could do in an overguide of 540 days and an underguide of 480 days. And the ROTAC then can balance the different surveys and decide the best approach. Okay, so that's what we're doing, is figuring out how to do this. Here's the High Latitude Wide Area Survey Definition Committee members. So there's all these lovely people. I think this is probably the most distinguished and knowledgeable group of people I've ever worked with on anything. And so it's been a pleasure to engage with all these folks. I know that at least a few of them are on the call here today. So I'm the co-chair of this, along with Risa Westcliff from Stanford, who wasn't able to make it today. And we have this other list of wonderful people who have been contributing to all this. Okay, and so just to give you a sense of where we are in the survey process, we had our kickoff meeting in February. We went through a whole process of sort of ingesting and reviewing all the white papers and science pitches that were received. And then we did some reviews and other discussion of science ideas in the spring. And this summer, we've gotten into the process now of exploring trade spaces and looking at outstanding technical questions, and actually have divided into different working groups, focusing on different aspects of our multi-tier survey, which I'll describe in just a minute. And so in the past couple months, we've been starting to report back to the community. So we've had two main opportunities to do that for this committee. One is a presentation at the Roman Science Conference, and the other one is here we are today, the virtual town halls today and next Thursday. And then over the next couple months, we'll refine these trades with additional technical input, and I'll talk a little bit about that, and our report is due in November. Okay, so this is where we're going. We're in the process of sort of evaluating these trade spaces. What I want to start with is just a quick overall view of sort of distillation of the large amount of work that was done defining the reference mission for the survey, which basically, as we pointed out before, demonstrated that Roman was able to meet its level 1 science requirements. So this was sort of the place that we started, and we've ended up somewhere a little bit different, and I'll describe where we're at, and then we're continuing to do trades around that. So the reference design basically had two components. One was a very large 2,000 square degree area designed to measure 100 million galaxy shapes and get 10 million galaxy spectroscopic redshifts. And so this is done by imaging in 4 near infrared bands, Y, J, H, and HK. So they go approximately from 1 to 2 microns and getting down to 26 to 27th magnitude. And in the reference mission, we had 4 dithers on each pass and multiple passes. This allows really good sampling of the PSF and covering chip gaps, et cetera, with a nominal exposure time of 140 seconds, which sort of optimizes roughly the number of galaxies that you can get. And I'm happy to have some more detailed slides later on if people have questions about this. And then in spectroscopy, we have 4 passes with separate roles in order to be able to do spectral decontamination with an exposure time of approximately twice that of the imaging survey. And then in addition, so the main survey as designed in the DRM was this 2,000 square degree survey, and it was shown that that provides the statistics that we need to do both the imaging and the spectroscopic cosmology measurements. And then the survey dedicated approximately 10% of the time to a significantly deeper observation in a small area, 20 square degrees, that would be used for calibration primarily. Although there's lots of other sciences we'll see that we can do with that. Okay, so this is sort of where we started. One thing to point out with the imaging, just, there's the Roman field of view. Many of you have probably seen this. Well, it's in the logo. The Roman focal plane for the wide field instrument looks like this. And so there would need to be multiple dithers, and then a tiling strategy, and then multiple rolls in order to fully sample the PSF. And this has been explored in some excellent simulations, one of which is presented in this paper by Troxel et al. And here's just a tiny example of the sort of sets of simulated galaxies that you might see. These sort of look familiar to anyone who's used to Hubble data, but we will have 100 million of them. So, it's something, it's entirely multiple new orders of magnitude. If anybody's seen previous talks on Roman, survey speed is 1,000 times what we can do with Hubble. And so this is an entirely new parameter space. Okay. In terms of spectroscopy, in order to reach the, to get the numbers of galaxies that we need out to the redshifts we need, sensitivity of a little less than 10 to the minus 16 ergs per centimeter squared per second in an emission line for a point source is what was required. At least it was defined in the reference survey, and this would yield about 10 million H alpha redshifts and another 4 million or so O3 redshifts. And there have been a number of trade space studies already in terms of working this through, but that's the basic parameters that the reference mission illustrated would be possible with the kind of exposures and number of return visits that we were talking about. Okay, so that was sort of set up basically for the cosmology, but a large driver, or a really important driver for what we're doing as Roman, is survey science and broadly, general astrophysics across the board. So we got lots of white papers. Here's a nice word cloud of a lot of the input that we got. And, you can see there's a lot about galaxy evolution, but there are many, many different amazing science cases that you can do using the kind of data that we're describing here. And so we got a lot of input from those white papers and synthesized that and tried to think about how we could optimize the core community, or sorry, the high latitude wide area survey design in order to not only reach the science requirements, but also do as much as possible of this other science. And this goes, just to run through very quickly a few examples, this goes through solar system objects, ultra-cooled dwarf stars, resolved stellar populations and low surface brightness ruptures in nearby galaxies, emission line diagnostics and AGN black hole evolution for more distant galaxies, and then studies of the very distant universe at cosmic dawn and galaxy evolution in clusters, for example. And these are just a few examples of the white papers that were submitted for this. So there's a whole huge range of science that you can do with these amazing observations. Okay, so we kind of put this all together. We did a whole process of reviewing and cataloging and engaging with all of the input that we got. And there were sort of two main takeaway points that came from all of that have fed into what our nominal design looks like. And so in response to the white paper and science pitch input, one point, and there are many other things I'm just summarizing here in trying to distill it to these 2 points. That many of the science cases emphasize the value of a deep field that's relatively wide. So something with the kind of depth that we're talking about with our deep field, a factor of a few or so deeper than the wide area, that kind of, there's a lot of great science available with that. And if you can make that field as wide as possible, that's great. And so then we're therefore exploring deep fields larger than the 20 square degrees in the DRM. And then there were also a number of white papers and science pitches talking about the benefit of an extremely wide shallow survey in a single band. So taking advantage of Roman's large field of view. There's a huge number of general astrophysics applications you get from just getting really high resolution and sensitive near infrared images. But it also maximizes the number of galaxies for weak lensing measurements. And so in a way, this kind of survey would optimize the statistical precision of the weak lensing measurements. However, and this is really important, this would come at the cost of a systematic uncertainty due to the lack of color information, due to two things. One is that chromatic effects in the PSF. Another is uncertainty in photometric redshifts. And so relying solely on that would introduce some additional systematic uncertainties. And so we're exploring a design with an additional single band wide tier, but that will not be the only wide area. And I'll go through the details of that in just a second. At least that's in our nominal design. Okay, so what is our nominal survey plan? At this point, we have introduced an additional tier. So the DRM had 2 tiers. This has 3 tiers: a wide area, a medium area, and a deep area. The medium and deep tiers broadly correspond to the design reference mission in terms of bands and depths, although there's some adjustment in area. In the ones that the point designs we have been considering, the medium tier is a little bit smaller, and the deep field is a little bit larger than what was in the design reference mission. But then on top of that, we have added in a wide tier that provides additional area in a single band for both cosmology and general astrophysics, as I described before. So this is the general picture we have. I have in my slides at the end some more details of one iteration of this, if you're interested in looking at some more detailed numbers. So please feel free to ask about that later. But this is the general idea that we have. And just in terms of the wide tier, to say that the depth of the wide tier is broadly comparable in a single band to the depth in the medium tier in multiple bands is just, we don't have the color information. So we have this, we sort of, after ingesting all the white paper information, this became clear as the sort of broad framework we would think about. But there are a lot of complications and potential trade spaces to think about in terms of depth and area bands, field location, and how we do the observing strategy, et cetera. So I don't have time really to go through all the details of that, but I'm going to kind of touch on a few of those as we go along here. Okay. So in terms of trade spaces, in the medium tier, the depth of the medium tier is broadly set to maximize the number of galaxies we can get for shear measurements, while also including some color information. And that's where approximately we get to that area of about 1,000 square degrees to 2,000 square degrees, and approximately 140 seconds per exposure that I mentioned before. So that came out of the design reference mission, and we're kind of sticking to that. The medium tier, one important question, and this is something that we're looking at with individual point designs, is that the medium tier can be a uniform medium tier over the whole, say, 1,000 square degrees, or it can have a larger area with a little fewer bands and a smaller area with more bands, so that you can do sort of a nested set of calibration, as it were. And that's one of the things that we are aiming to be able to simulate. So that would actually lead to something you might think of as a 4-tier design with two, say, 100 to 1,000 square degree tiers in the middle. In terms of the deep tier, in terms of the depth and area bands, I think that having a broad range of color information for the deep tier is critical. So we're not thinking of dropping down too low in terms of the number of bands there. But there is a trade-off in terms of depth and area. If you need to get deep enough to be able to do the calibration, and we're studying exactly what that means. I'll mention that again later. But you could go deeper, which would optimize more for the high redshift science cases, or you could do wider, which would give you larger galaxy numbers, both for calibration and some other galaxy evolution studies, and also would mitigate cosmic variance. So we're sort of looking at that as a trade space. And then there's the possibility of including additional filters. So we had a number of white papers that advocated for adding in the longest wavelength filter, the K-band filter. This actually was, the K-band filter was not available. It wasn't in the mission design when the design reference mission was proposed. And so this is something that we are considering as well. It is significantly less sensitive than the other bands. And so how those tie in together makes a difference. And I'll touch on that again in just a minute. Okay, so that's one thing, is the depth and area bands for these medium and deep tiers. Another trade area is just where do we put them? We have the whole sky in some sense as our playground here. So it is a little bit complicated. There are some considerations, some of which are more straightforward to address than others. I won't go through all the details here for the interest of time. Please feel free to ask about this later as we go through. But some of the things that we've been considering are complementarity with both the wide tier, in terms of where that's at, and the high latitude time domain survey. Overlap of the field regard of ground-based instruments. So some of those are shown here by some north and south boundaries of what's observable. Overlap with wide area surveys. We had a lot of white papers, in particular from Euclid, Rubin, and Subaru, talking about the amazing synergy that could happen with Roman observations of some of their survey fields. And so there's a lot of interplay there. There's also some really interesting considerations with regards to solar system science and what we could do. And generally that means putting part of the medium tier somewhere in the ecliptic plane, or see somewhere relatively close to the ecliptic plane, which has the downside of introducing potentially additional zodiacal foregrounds. So there's a trade-off there, but we've been looking at some of that. Considerations partly is just the timing of these fields, which fields gets done first once you define where they're going to be. And also, and I'll get into this in a moment, but how many deep fields, and as I mentioned before, what the zodiacal foregrounds are. So this all comes in there. It's and as I'll talk about later on, there are questions about how many, not only how many deep fields do we have, but also how many wide area, or sorry, medium area fields do we have? Do they need to be contiguous, or can we split them into multiple pieces? And what are the impacts of that in both cosmological measurements, understanding of cosmic variance, and the way that they potentially would then be accessible to various telescopes? So there's a lot, there's a lot that goes into this. Okay, whoa, what happened? This ended, oh, there we go. Okay. And then the last sort of set of trade spaces I want to go over is with the wide tier. We have done a lot of thinking about this. This is obviously a new piece, as I mentioned before, compared to the design reference mission. And so just to go through the overall thinking on what the wide tier would look like, one important piece is that you would need sufficient sampling in order to enable the weak lensing shape measurements. And so that makes it necessary to do multiple dithers and potentially even multiple passes in order to fully sample the PSF and cover the chip gaps, etc. The most efficient band for doing this kind of work would be the H band, the 1.6 micron band. And so that's where the focus of that group has been. I'll discuss other possible bands in terms of the places we didn't go in just a minute. So the idea here would be to then balance depth versus area to just maximize the number of detected galaxies. So basically to improve the statistical constraints on the weak lensing measurements. And by doing that, you also cover a lot of the general astrophysics science that was proposed for very wide area surveys. The thinking of the group, we had a sort of one working group that was looking at this. The thinking of the group was that would mostly be the southern and equatorial sky, if not all, to overlap with both Rubin and the sensitive new CMB surveys that are online and are coming online. And so the thought in particular, the sort of overall strategy, as I mentioned, well, that was laid out by this group would be to do a single pass, but with multiple dithers to do at least covering of the chip gaps. But there may be an argument for doing actually multiple passes, and that's an additional consideration. And in terms of schedule, it may be preferable to schedule some of this after some or all of the other areas so that we have some data to work with that could help inform what the optimal strategy is for doing this wide tier, and to understand, for example, what some of the systematics and shape measurements might be, et cetera, et cetera. So we're thinking about that programmatically, how possible that is. It's not quite possible to say at the moment. So I just want to highlight at the end of this discussion some of the things that our group has not chosen to go down at the moment in terms of our thinking. There were a number of white papers that advocated for using the wideband for doing a wide area survey. The big advantage of this is that you get deeper in equivalent amount of time, but the problem that has become clear from looking at this is that with a very wide band, there are really significant systematics in terms of understanding the PSF across that broad band that our group felt like, along with input from others, would not be tractable in order to be able to, at least would produce an unacceptable level of risk in order to be able to do weak lensing measurements with this. And that's sort of a critical driver, as I mentioned above. A number of folks also advocated for doing a K-band survey, which would be also amazing. There's a lot you can learn with long wavelengths, but given the limited sensitivity for the core community survey, where we're limited with time, we have felt that H-band would be optimal. And then a number of surveys or a number of white papers advocated for doing a very large area, either the whole LST footprint or the whole LSST footprint of the whole sky. And the problem that comes up with that is, again, some difficulties in being able to use those data for weak lensing, in particular, that you would probably only be able to do that with a single dither in the sort of time that we have. And that would limit our ability to do weak lensing measurements just due to the undersampled images. And so although, and I'll mention in a moment, these are all things that are very exciting and potentially could be done with Roman. They're not what we are currently considering here. So ultimately, just again to say that as a note at the bottom here, the overall scale of the wide tier is limited both by our total observing time that I mentioned before, and by the fact that we have to meet the level 1 cosmology requirements with particular confidence in the systematic errors, etc. Okay, and one other thing just to point out, which is for those who have thought a lot about wide area surveys with Roman, one issue that we run into when you're doing very shallow measurements across a large area is that you start to become significantly overhead dominated. So most of the time involves actually slewing and settling rather than doing some exposures, and that trades into exactly how many galaxies you detect, etc. So I have a slide later on. We can talk about that if that comes up in questions. Okay. Lastly, I'm about at time here, so just to say that we're actively working with the Roman project and the project infrastructure teams, which are teams that are developed to look at a lot of the technical aspects of this. And there are a whole bunch of technical questions that come up, that have come up, that will inform what the ultimate trade spaces look like. So, for example, what are the minimum area and depth for the deep observations to be actually able to do the calibrations of the wider tiers, which was the prime driver for doing the deep survey in the first place. Can we do a single pass, say multiple dithers at a single roll angle? Is that actually enough to accurately model the PSF? So could we use that for the wide tier? If we have only 2 bands of imaging, which was one of the ideas for this 4-tier survey that I talked about before, is that sufficient for then being able to do decontamination of GRISM spectroscopy so that you could actually do a successful spectroscopic program over that area? What are the technical considerations for contiguous fields versus splitting tiers? As I talked about before, whether or not we want actual, some things in the north and the south. And one thing that has come up recently is the potential really exciting power of doing CMB cross-correlation along with the weak lensing and clustering measurements, and what impact would that have on the cosmological measurements, and is there an optimization we can do there? These are just some of them. We have a whole big running list of technical questions, and we are in the process of sending those out to the pits to get some answers over the next month or so. Okay, so I'll finish there. Just to highlight again what Ori mentioned, please do send us some feedback. So there's a questionnaire here. Here's a QR code. You're always welcome to email myself or Risa if you have questions about this particular survey. And I guess I want to finish by just saying that the science cases presented in the white papers and the science pitches are really amazing, basically across the board. And there's a lot of things, sort of studies of nearby galaxies and resolved stellar populations and lots of nearby galaxies is a great one, for example, that would be an amazing use of Roman, but wouldn't necessarily work in the context of the limited time and the cosmological requirements that we had for the core community surveys. So I would encourage anyone. So hopefully a lot of the science, well, we do know that a lot of the science that were presented in the white papers will be able to get done with the kind of nominal plan that we're talking about here. But if it's not included there, all that stuff would make really compelling general astrophysics surveys. And Roman, of course, has a large amount of time set aside for that. So I would encourage everybody to think about those as well. Okay, I'll stop there. Thanks.
Thanks, Ryan. So plenty of time for questions. And we can start off with a question from the chat from Yun Wang, asking if there's no spectroscopy mode in the wide tier.
We have considered that. I think ultimately, the time constraints really limit you for being able to do spectroscopy over that large area. So that's something that was considered, but the trade-offs there, we would take up quite a large amount of the overall time, and most of the clustering measurements, at least the cosmological measurements, there's quite a good amount of margin for being able to complete those using the spectroscopy just in our sort of nominal medium tier. But it's a good question. I'm trying to figure out how I find the chat because I can't, since I'm presenting, I don't see it here. Let me see if I can find it.
No problem.
So if I may comment on what you just said, what you
Sure.
just said is actually not true. Okay, so if you're not doing spectroscopy in the white tier and you reduce the survey area in the medium tier, then the galaxy clustering requirements will not be met. So I'm doing the requirement verifications. I can tell you that.
Okay.
That can be verified independently by other people.
Okay, that's a conversation that we definitely should have. I mean, my understanding from the design reference mission was that there was quite a lot of margin in terms of for the BAO figures of merit and in terms of what was possible in a 2,000 square degree survey. But if that is different now than it was at the time that the DRM was proposed, then we should certainly discuss that.
So actually there was a mistake in the RSD figure merit. I'm trying to verify, then I discover it's a factor 4 discrepancy.
Okay.
So yeah, so this is a discussion. I think you should not assume there's a lot of margin in meeting those requirements. They can be met if we indeed have 2,000 square degrees of the design reference mission. But if you're going to cut it down, then you're endangering meeting the mission requirements in dark energy using galaxy redshift survey. That's just a fact.
Okay. This is definitely some information that we will flow back and forth with our committee. See where the questions
are. All right, we have plenty more time for questions, and feel free to kind of raise your hand, and then I'll call upon you. Okay, there's another question in the chat, which is there an efficiency cost for doing multiple wide fields?
in terms of spreading the wide fields across two separate areas, for example, I think the answer to that is not really. There's some moderate efficiency cost to if you start spreading lots of chunks all over the place, and then the sort of scheduling becomes more complicated. But in terms of quite wide area contiguous fields, there's sort of an efficient tiling pattern that can be worked out that would make best use of the sort of overheads for doing surveys. So I think that there's not doing multiple fields. Just if you say you did 2 or 3, that would not be a huge efficiency cost.
Okay, great. So whilst we give folks a couple of minutes to think about questions, I'll say, so this is the third one of these, and we'll be doing 3 more next week. Each of the 3 surveys will be having their second session. We have each one gets a time that is friendly for the various time zones. So this is the West Coast and further west or further east, time zone. friendly session. Another reminder that we do have a monthly community forum. This month we had presentations on the recently delivered wide field instrument, showing images from the wide field instrument and discussing that. So if you want to see real data coming from the instrument, those slides will be posted online shortly, and encourage you to join us for those monthly events.
Great. We have another question in the chat. Preliminary thoughts about what areas might be particularly good or bad candidates for the wide field. The thinking that we have, so as I pointed out, maybe I can go back to that slide that just shows the sky. The considerations on precisely which fields you go to are complicated because if the maps of the sky that are covered by multi-wavelength data, which a lot of the survey, or a lot of the general astrophysics science in particular that we were interested in, is greatly enhanced by having various forms of multi-wavelength data available in these different fields. And so it's really not, the details of that are not trivial at all. But in terms of the wide area, where we're talking about around 4,000 square degrees, the consensus of the group is that it would be best to focus that on equatorial and the southern sky, because that's then where we get overlap with Rubin, which will provide a huge amount of additional information, both in terms of just photometric measurements and time domain information. And there's also overlap there with the most sensitive ground-based CMB surveys. And actually, the cross correlations with the CMB may be most valuable over quite wide areas. And so so that's the thinking. Exactly which 4,000 square degrees one would choose in the equatorial and southern sky is something that we're still thinking about carefully. So I don't really have a great answer for you on that, other than there are other considerations like ecliptic latitude, for example, and again, where different multi-wavelength surveys, large area multi-wavelength surveys are located. And just to point out one other thing in terms of survey location, it was pointed out in the chat to me that actually, in terms of the question of do we have one big contiguous field or multiple fields, if you have some big chunks, a relatively small number of them, that may actually make things easier for scheduling, given the constraints on where Roman can point. So in the end, there's a sort of optimization game to be played there.
There's a follow-up question there for you, Ryan, that is to follow up on this. Is there any interaction between the efficiency of wide field footprint and the medium deep fields?
That's certainly all being considered together. I think that's a good question. The medium deep fields, especially for the deep area, overlap with existing multi-wavelength data is a bigger priority, because you start to reach in the areas of tens of square degrees, 50 square degrees, you start to reach areas where there's actually is fairly deep coverage at a number of different wavelengths. Say, for example, in the deep coverage, I mean, for example, in the radio or in the X-rays, there are survey fields that have gone quite deep over those kind of areas. And so I anticipate that they will again be a relatively small number of contiguous fields in the deep area compared to the deep and medium areas, and compared to the wide area. But the trade-offs in terms of where exactly you go in order to maximize all that additional science is different in those particular areas. So I don't know if that, I mean, one, I guess, last thing to say is that the tiling strategies will probably be pretty similar in these different fields for the observations in a single band. They'll look something like the tiling strategy that I showed earlier. So whatever is efficient for the wide area would be also presumably fairly efficient for the medium and deep areas in terms of tiling strategy. It's that you would be going back and you'd be doing then multiple filters as opposed to just one.
Okay, thanks, Ryan. And I haven't seen any more questions come in. So I think with that, we can end it. Thanks all for joining, and please join us for the sessions next week. And thanks a lot for the great discussion and the good questions. It really helps us define this as improve the definition here and make sure that this is really serving the science community. So all the best. Take it easy.
Thanks, everyone.